Hey everyone, welcome to this last session of the Edge track. I'm very happy to see that still that many are with us, and I'm very pleased to introduce here a panel of experts for the topic serverless. And if you think like me that's about Lambdas and Azure function, probably not so much. So let's introduce. On the left side you see Alex Ellis. He is from ADP, he's a Docker captain. And then Erika Windish from IOPipe. And then Chad Arimura, sorry, I hope I got this right, from Oracle. And then Phil Estes from IBM, also a Docker captain. And then, of course, our very own Patrick Chanson. He is also the moderator. Well, take it away, Patrick.
All right, thanks. So thanks for coming. I think this should be a super interesting panel. In the keynote yesterday, one of the topics that Steve talked about was that as part of the future developments on top of container platforms such as Docker, you have serverless. And in the case of Docker, it would be serverless anywhere. The goal is to have a serverless platform that really runs everywhere. There are lots of projects around serverless. So here you have a good representation of some of the very successful projects in terms of serverless framework. So we'll go into 4 sections. First, I'll ask each of you to introduce yourself and talk about your project and how it came to be. Then I'll ask each of you to talk about the serverless community and how things evolved there and what you see on the horizon. And then talking about the architecture of your project, what's unique about it, and then talking about use cases, what you saw in terms of customer use cases, things people want to do, and things people shouldn't do. So let's go about the introduction. So Phil, do you want to start?
Sure. Like the introduction, I work at IBM. I'm going to let everyone down and say that I don't actually work directly on the IBM OpenWhisk open source project, but I've worked a lot with that team because it's based around container runtimes. So we couldn't get someone here from OpenWhisk, but I'm here to stand in, so we'll see if I can hold my own on the panel. But more importantly, IBM created a open source project called OpenWhisk. It was then contributed to the Apache Foundation, where it sits today. We've got collaborators like Adobe and Red Hat and others. We then also use OpenWhisk in our IBM Cloud Functions cloud-based public cloud service. So I'll be talking mostly about OpenWhisk as an open source project, but we also have our public cloud offering.
Couldn't even show up to the panel. Shame on OpenWhisk. Just kidding. My name's Chad Mira. I was formerly the co-founder and CEO of a company by the name of Iron.io. We were sort of jumped into serverless back in 2009 when we created this app this service that could allow our customers to easily zip up pieces of code, send it to us. We gave them an API to execute that code, and that was it. We scaled everything behind the scenes, ran it all on AWS at the time. And if you fast forward about, 8 years now, it looks a lot like what people are doing today. So we started writing articles in 2010 called The Future is Serverless, really with no indication or idea that it was going to become an entire category of computing. So it's pretty cool to see. So we did that for 7 years and then sold the company. We joined Oracle so we built Iron Functions previously, which was an open source serverless platform. And about 6 months into that, we joined Oracle and founded the FN project, which is a major fork of Iron Functions, all around this serverless stuff. And I'm sure we'll get a chance to talk about that today.
Hello. Okay. So I'm Erika Windish with IOPipe. And so what we're doing is providing observability into serverless applications. Right now we support Amazon Lambda. So I have a deep knowledge and history of what really Amazon Lambda is doing. Before IOPipe, I had built a serverless platform, released it in 2009, 2010. Really couldn't users really couldn't resonate with the service then. So I ended up working on clouds and worked at Docker for a bit. And then saw what Lambda was doing. I thought that was really exciting. Started working on kind of a portability for serverless applications and try to kind of do like, my vision was kind of a Docker for Lambda. Also didn't really resonate with users, so we really talked with users, figured out what they wanted, landed on observability and monitoring. So that's what we're doing now. And I think it'll be an interesting, conversation, to kind of figure out, our backgrounds here.
Hello. Many of you already know who I am, and it's great to see some of the OpenFAS contributors in the second row there, and some new contributors too. And I think really, when you look at OpenFAS as a project, it's very similar space to what the other panelists are working in. But there's a bit of a difference there, which is that it's come from the community and it's not presented by a vendor. And I think that helps a lot of people to kind of evaluate it and not feel like they're going to one company or another. It started off as a technical POC because at the time I was working with Lambda and I found it too clunky as a programmer, as a developer. I was used to CI and Docker containers, and I suddenly had to zip up code and install modules locally, and it didn't make sense. It turned out it was really interesting, and it got to the DockerCon Cool Hack contest in May, and they had this remit, push Docker beyond what it was designed to do. It was really hard to actually get it accepted, but when I did, everything came together, and this is the journey since then. And it's been rebranded as OpenFAS, and it's really a community thing now. So, thanks.
Great. So next topic. So the first topic I'd like you all to give your opinion about is what is serverless for you? Because I've seen lots of different definitions. Usually the talks about serverless start by half an hour of defining what this means. So let's make it short, like a few words about what it means to you. And then where do you think the ecosystem is in terms of serverless? Because there are lots, more and more projects. In CNCF, the Cloud Native Computing Foundation, there's a serverless working group that just created a report recently. So where do you think the ecosystem is, and where do you think it should go? Phil, do you want to start with that?
Me, all right.
You shouldn't have seated next to me.
Yeah, I know. See, I told you. I was. Yeah, so, like you alluded to, there's obviously a lot of back and forth, these terminology definitions. As you also talked about, the serverless working group is writing that white paper and sort of looking at next steps. So, differentiator in sort of our world, the OpenWhisk project is basically functions as a service implemented. And we see our public cloud offering, IBM Cloud Functions, as having that serverless idea conceptually in the cloud, where it's connected to our services, our backend, our networking, our storage, and so having that set of layers that now my functions are sitting in this world of external services and built-in functions that are available, like weather and other capabilities that are already in our cloud. That's the distinction we see really, is sort of the implemented functions as a service framework, and then this serverless environment in which people can say, I only care about my code, you worry about running it, you worry about scaling your servers, and so on. So I think that's it for us.
All right.
Let's see, so definition. People are getting hung up on definitions a lot right now. I think rightfully so. We got hung up on cloud a lot. And then we realized that it's actually not in the sky, it's here on the earth. Serverless is similar, where of course there are lots and lots of servers, but we just don't think about them. And with cloud, we don't think about what's sort of in the data center anymore. But I kind of zoom out a little bit and think about serverless as not a technical definition, but more about a philosophy. At the end of the day, it's about delivering value to our users. As a developer, we write code because we love it and we enjoy it, but we write code because we want somebody to use and consume that code. And in order to use and consume that code over time, it has to improve and get better and listen to market trends and be able to react. And to do that, you need an architecture that allows you to scale and innovate and be agile and move quickly. And I think it's an architecture or a philosophy that allows us to do that by raising the abstraction line, not thinking about servers, not thinking about infrastructure, but sort of taking advantage of all the power of the latest technologies like cloud, but not having to think about a lot of complexities of it. Of course, with that, we get a great economic model. I don't think that is a big part of the story, but not necessarily part of the definition per se to me. But yeah, that's what we're really excited about serverless. It's all about developer empowerment.
Yeah, so I mean, serverless is a lot of things, and both Phil and Chad, you both hit on some really great points here. So like serverless as an architecture, you build your applications. They are very, very fast, immutable, ephemeral functions. They are event processors, right? So you evoke functions and they process events, and it has to do it really, really fast. Within fewer than 100 milliseconds. Less than 50 milliseconds. Ideally, less than 20 milliseconds in terms of invocation of starting that process of the code and then getting the responses back to users. And this is an enforced model. So just like with Docker, you can do 12-factor apps, you can do microservices. With serverless, you have to build nanoservices, and it's stateless. So because it's stateless and it's ephemeral and it's immutable and all these other things, you become very dependent on the cloud services that are available to you. So hello? Okay. So what's interesting is that things like OpenFaaS, and I love to hear what what you have to say next, is because when you build your own, when you run it in your own data center, you may or may not have all those other cloud services available to you, right? Or you don't have the integration with those cloud services. So when you're running on Amazon with Lambda, you get Kinesis, right? If you want to use Kinesis with your own FaaS that you built yourself or installed yourself, how do you do that, right? So then you have to build some serverless things to consume it, or you can run Kafka and consume it. So there's definitely going to be a lot of work around the edges, right? It's those sidecar services and things that become really compelling and interesting, and really understanding that story and figuring out what you're going to do there. I'm sorry, I started talking about other things. Anyway, your turn.
So the question was, just to repeat, what is serverless? Is that right? Okay.
That's okay. Actually, Erica started to dig into the architecture, which is the next topic, so that's good.
No, I mean, just I'm sort of at the end here, so I think I get the opportunity of kind of mopping up the crumbs. But when I look at serverless, and I always start talking about it in this way, is that forget about the terminology. It's an architectural pattern. It's the experience that you have as a developer. It's about, and I think I had a conversation with Dan Cohn yesterday at the CNCF. It's about deploying fast, being the quickest to iterate. And I think when teams are looking at delivering a service to production, whether that's on their on-premise cluster or maybe through Lambda or something similar, it's the speed at which they can iterate and how reliable that is. Now, when you come to start using Docker containers, you have this whole new job, DevOps, that is about automating, about knowing what to put in a Docker file. There's so many choices, and I think Lambda is great because it takes them away from you and says, well, look, we figured it out, and with OpenFaaS, that's what we're trying to do. So when we will build a function for you, we'll use non-root users, we'll use multi-stage builds. And to speak to Steve's point in the keynote, he said, serverless, no lock-in, run it anywhere, even at the edge. Okay, how are you going to do that if you're locked into a cloud provider? Okay, so when we look at OpenFaaS, we're considering that a Kubernetes or Docker Swarm scheduler is the level we need to target, and that's what helps us do that.
And actually, that leads us to our next topic, which is architecture. And okay, this time we'll just go the other way, so you can start, Alex. I'd like you all to talk about the architecture of your framework and what you expect from the underlying container engine, and also what would you need in order to make that truly portable across any type of infrastructure.
Can I add one quick thing?
Sure.
I just want to make it clear to the audience, because this is also a confusing point about definitions and serverless. Functions as a service is very commonly equated with serverless, and I know we've talked about that. You mentioned, rich ecosystem, having peripheral services. Functions as a service is a component of that. Typically, it's the compute component of that. So when you hear FaaS, you think the compute portion of a serverless architecture. That's starting to sort of glob as the primary definition. It's a portion of serverless, but serverless itself as a category certainly encompasses a lot of different pieces, and I think that's what we'll start to dive into.
Oh yeah, and actually, so I'm going to add to that question. I'd like you to talk about events as well. Like what type of events do your framework respond to, and how do you think that should be standardized across the different type of event sources in order to really make the application portable?
Can we do that one next and just start with the architecture? So It might be a bit too much to do at once.
Yeah.
So the architecture of OpenFaaS is quite simple, and that's the feedback I hear from people that are using it, and that's one of the reasons that they opt to use it. There's an API gateway that's written in Golang, and that's effectively your gateway into all of your functions. It's where you deploy them, it's where you define them, it's where you set what secrets they need to use, environmental variables, and whatever else. We have Prometheus just underneath that, which gives you cloud-native metrics, so you can get operational idea of how things are going. At the same time, we also use that to be able to scale up as demand increases. And that leads me into the next point of the architecture, which is using containers as the primitive. Every function that you have is a container, and we build in the function watchdog, which is another Golang application. It's a very tiny Golang web server. Okay? It just has one job, which is to fork your process, read from the gateway, push it in through standard in, read from standard out, and then return the value. Now, standard and standard out go back to the beginning of Unix. Right, so we're going back to beginning principles, and it means that something like ImageMagick, which is a binary, doesn't know anything about the web, can become a function, and we can scale that. Okay. A lot of the other frameworks are much more opinionated, and they say we must take a JSON header in this format. And the reason they do that is to work with queues in a more integrated way. Okay, but with OpenFaaS, you can build as a function in code, or you can build as a binary, and it works the same. The other component there is the Docker image. So that's what I just want to make clear, is the Docker image is a primitive. So we expect the scheduler to schedule that on a node, and when we scale it up, for the scheduler to make the decisions of where that should be, to rely on the round-robin DNS, to rely on resolution if we're running a MongoDB in there, in the same namespace, to be able to reach out to things. Okay.
All right. Erica?
Yeah, so I don't have a FaaS as a service, right? But we do provide observability, APM tools for Amazon Lambda. The agent portion of that, which is code that you add into your functions, is open source, right? So that is an open source component that allows you to grab information. And it's interesting, right? Because what we do is we recognize that developers are the ones building these applications, deploying these applications. So we hook in not at the container level, of which there are containers on Lambda, which is what we support currently, and we can support other platforms such as OpenFaaS and OpenWhisk and FN in the future. Right now we're going where the users are, and the majority of users are on Lambda today. That will, there will be more users on other platforms as time goes on. But developers, right, it's developer focused. So the developers are writing code. So we integrate at the point of developing that code. And I think it's interesting. So what we're looking at is we're looking at the container, we're looking at the VM, we're looking at the application and its runtime. So that's mostly what that's the basis of what we're expecting is, language runtime and the ability to put things in code. But it's a little more than that, right? Because we're also expecting, we have common event sources. So, the Cloud Native Computing Foundation, there's, they're working on standardized event sources, which are really interesting to us because, what we do is we also look at things like event sources so we can create metrics and observability around that for users. And I think that, a big part of the story, because serverless is stateless and your applications do depend on external services, whether or not they are microservices that you build or they are cloud services that you consume, you become highly dependent on them because that's where all of your state is. So, that's a big story for us, is in understanding that data and developing a story for a user so we can present that to you, and grab that, with our, I guess you can call it a framework, and it's really more of an SDK.
So what Alex failed to mention was I like to think he was largely inspired by the architecture of iron functions, given that our
in what way?
Our architecture is very similar. So our fork of FN project, so the FN project is similar to OpenFAS in the sense that Docker, we believe that one of our primary key values is that Docker is a native sort of format we support. It's how you package up your functions. It's how you deploy the FN server. And so if you think about the architecture of FN, we have the FN server, and we have a load balancer that sits in front of that. You can use any load balancer that can do round-robin DNS and load balance between the FN servers. They're all stateless, so you can spin those up and spin them down at will. We have a smart load balancer that can handle scaling of the FN servers, so you can auto-scale behind the scenes. It will kind of detect whether there's functions that are waiting to run on a particular server, and if they are, it'll scale out and scale back. And then the server has the logic for deploying functions. Functions are packaged in Docker containers. We abstract out a lot of the Docker kind of stuff that you have to do. So you can get started with a simple FN init, FN run, FN deploy, and that will actually do a multi-stage build like Alex was talking about. It'll build a container, push it to a registry, and then the first time you call that, it will get pulled over to the server and ran literally like 3 commands, 15 seconds. So pretty powerful. It can run on any orchestrator. So if you're using Kubernetes, you can launch it on that. If you're using bare metal, you can do that. It can pretty much handle the infrastructure scaling itself. But you can plug it into any orchestrator if you want. It can run on any cloud. It's open source today, and also independent of Oracle. The team right now is employed by Oracle, but it is an independent project, so it's under FN project for GitHub. So the architecture is pretty simple. Definitely take a look at it.
All right. So I'll tell you how to find out the OpenWhisk architecture. You go to github.com/apache/OpenWhisk. Scroll down to the architecture diagram. There's a great block diagram there. Obviously I'm not the expert on OpenWhisk architecture. However, obviously message queues are involved. We have the web actions, the HTTP entry points. That all leads to a core, which again, like OpenFAS, like FN, is built around the Docker engine, based around the idea that function packaging is easiest in a Docker container. The interesting twist is that there are a set of pre-built runtimes, so similar to Lambda, classic runtimes for Node, Swift. I think we have PHP now, Python. But if none of those meet your needs, you can build a Docker file, say from OpenWhisk, and take a base image, add your own content. I used this recently when I built my manifest list query tool. I had a binary, obviously wasn't going to be able to turn that into a function. Put that in a container, send it to OpenWhisk, and now I have a triggerable function in my own Docker container. So yeah, we believe, I think, the power there of that model. But again, having those kind of pre-built runtimes means that people that are more familiar with the Lambda workflow, I just have some Node.js code, I want it in a function, that model works as well.
So to go back to the initial question about portability, or the original theme of portability, compared to the cloud provider version of serverless platforms like Lambda, Azure, or Google Cloud Functions, what do your framework would need in order to be made truly portable, and especially what do you expect from the underlying container platform under it? Like in terms of storage and events and things like that. Because today, as Chad said, a lot of these platforms just focus on the function as a service, but that's only one aspect of it. To be made truly portable, you have to take storage and events into account as well. So Phil or Alex, do you want to start on that?
Yeah, so I just want to say, it's great to have everyone here and the differences of opinions. OpenFAS started at the orchestration level. So it's not that you can run it on any orchestrator like FN. It actually trusts the orchestrator and uses primitive objects. That means it's Kubernetes native, and it is open, and it is Docker Swarm native. It doesn't just run on it and make use of it. It literally has objects inside it. I think that's the key point here. That means that we can make use of Docker secrets, Kubernetes secrets. We can pull your images from any private registry, and that integration is what we expect. So the Microsoft Azure team recently evaluated OpenFaaS as part of their Global Hack Day over in Seattle and some of the other projects, and we got some really good feedback. And one of the things I thought was interesting was Microsoft Azure Container Service only runs Docker 17.03. Right? You can technically run OpenFaaS on that, but because we're using multi-stage builds, and it's just on the client, we kind of expect people to be keeping up a little bit. Now, there are ways of going backwards, but I think one of the things we've got right now is we're thinking about managing configs, and Docker Swarm has a great way of managing them, but it's only available in 1706. So now you have the question, do you push up and break a few people and get them to merge and take advantage of the ecosystem? And as that starts to happen, because secrets and configs are quite new for Swarm, I think we'll see other things like storage, and maybe we can do integrations with things like RexRay or NetApp to make that whole experience. Now, as long as those things will run on the orchestration platform, and that's what we're all targeting, that's why we're at DockerCon, then I think you can take your application to any cloud, whether it's internal or external. Particularly interesting is the Azure container instances, which allows you to launch one of your pods actually on Azure and have the rest local. Now that's really early work from Microsoft, and it's not quite ready, but when you get there, you'll be able to have services in the cloud, maybe connecting in natively through IAM or whatever you like. Okay, in terms of event sources, we currently work at the lowest common denominator, which we believe is HTTP. If you look at any product, it will generally always support that. One of the users of OpenFaaS, the University of Calgary, has a HRM system and a research management system. And when they get a grant for money, they have an event that's published from one, and it's connected through Kafka to the other. And they wrote 90 lines of code in Python. That is literally it. It works great. They just added some metadata. And now that goes back to the fact that OpenFaaS is a framework. And we have a number of guides that help you with your reference architecture, but really it's for you to build as a developer, and that's what we find people do. They only get in touch with us when they actually finished it. Like, hey, look what we did. And we're finding that they don't need help, they know what to do.
I see. So you're advocating an approach with a very broad framework that people can then specialize based on the type of event.
So yeah, one of the values of OpenFaaS is open platform. The default way of doing asynchronous right now is NAT streaming, but we just had a PR from the community for Kafka. Okay, for most people, it would make sense to use NAT streaming, but for people who already have a Kafka cluster, they can integrate with that really easily. And I think the fact that that came from the community and the recent secrets work as well just goes to speak of the health of the project. Over 45 contributors, over 1,000 commits, and this started in January. Okay, we've actually had over 700 stars a month, every month, and it just seems to be going up and up. But if the community wasn't there, this project wouldn't be where it is. Oh, and that's open source for you.
Great. Erica, do you want to talk about portability in your space for observability?
Yes. So it's interesting, right? Because I come from a deep open source background. I was am a former Docker maintainer. I was a former core developer on OpenStack. So I very deep history of open source, and open source tends to value openness in platforms and the things that you can run. And however, one of the things that I love about Lambda is how constrained it is, that it's highly opinionated. It's not an open system. And like some of the open source, FaaS solutions are very open and allow you to do a lot of things, which is actually good, right? Because the highly opinionated workloads can run in an open system, right? It doesn't work necessarily the other way around, right? Workloads designed for the open system won't run on on a tightly constrained and opinionated system. But I love that Lambda is so highly opinionated because it makes portability easier. Because you can, if you say, I just need a platform that can run Node.js, or I need a platform that can JavaScript, or I need a platform that can run a jar file, and I just provide a jar file and I have a JVM. there's such, or say like, I can't write to a root file system and all I need, like the only thing Lambda gives you is a temp directory with 512 megs of storage that you can write into. And those kinds of strong opinionated design means that those functions written for Lambda could easily run on the IoT device. And in fact, Amazon even released something called Greengrass that allows you to run Lambdas on IoT devices. They allow you to run Lambdas on the edge with CloudFront, so you can run it on top of your, inside of your CDN. So there's this interesting balance between openness and flexibility, right, and the ability to kind of lift and shift your applications versus that portability, right? Because that portability is amazing. Amazingly benefited by having a strongly opinionated best practices architecture.
Supportability. Why do we want it? You have to step back and ask yourself, portability is about being able to run workloads in multiple vendors, multiple clouds, multiple regions, IoT devices at the edge. And so why do we want to do that? I think there are obvious cases for running functions on IoT devices. We want to process closer to the data, want to process closer to the user. But for running in different clouds or different vendors, it's all about data gravity. It seems to be all about data gravity, which vendor you've chosen to work with, which cloud you've chosen to work with. And it's about learning a technology that enables you to be able to deploy code in a similar fashion to all those different vendors and all those different clouds and all those different endpoints, not having to learn 12 different technologies or 4 different technologies if you're using all those different vendors, which ultimately when your company gets big, you do have all those vendors and you do have all those use cases. And so at the end of the day, portability needs to have a common model to be able to program against, and I think functions as a service is starting to give us that. Docker, obviously, is an amazing piece of the story, which is why we're all here. But you also need those cohesive services, the complete suite of services to allow you to do that. You need data services that are portable. You need other networking services that are portable. You need everything that sort of goes with that. Streaming services, you mentioned Kinesis. That's an amazing use case. And so, if you look at sort of the hype cycle, if you believe in the hype cycle, we're sort of at the peak of maximum expectation or inflated expectations.
Yeah.
So, right now we've got like tons of people jumping in. We got tons of frameworks. We got tons of vendors. We got, seed rounds and A rounds and serverless this and serverless that. And it's all the rage right now. But at the end of the day, we've got to deliver productivity and we've got to deliver agility and we've got to do this in a fashion that works for enterprises and companies who are actually building software. In fact, I met with a customer the other day, a large enterprise like Global 100, and they said, my developers want to be trying to stand up infrastructure more than they actually code because the hottest technologies and startups are all in infrastructure. So I think that's a sign of kind of where we are in the hype cycle, but I'm sort of mixing a couple questions. But at the end of the day, portability is about having all of those systems and having them be able to run in different areas. And so that's one thing I think that we're all focused on. We're focused on FAS, but also the entire ecosystem as well. So we're trying to push to get there.
Just one comment on that. I think as a community, our goal is to go through the trough of disillusionment real quickly to get to that plateau of productivity where we can all make developers more productive. Phil?
Yeah, so I think one of the things we haven't talked about yet, so I mentioned in the intro, is that OpenWhisk is an open source project no longer controlled by IBM. It's under the Apache Foundation. So how it's actually used is really up to those other participants. I mean, I can talk about IBM Cloud Functions, but that is one use case of OpenWhisk. And so OpenWhisk itself has been designed. You can self-host it. Obviously, you can on-prem with OpenWhisk. And so the portability of it being containerized, and I know there's been some work to run it on Kubernetes. So I think OpenWhisk as an open source project has built that kind of portability into its design and how it was created. When IBM brings that into our cloud, obviously, you mentioned events, so cloud and database or hosted databases, one of the most commonplace where triggering of events happens, obviously, chaining functions together. And then last week at Serverless Conf in New York City, the composability of functions, and so there's that kind of whole new world about 1, 2, 3, 5, 10 functions. I can kind of manage that, but how about when we're trying to compose an entire set of microservices? How are developers? How's that experience going to grow? And I think I guess I'm moving a little bit to futures, but I think that's where yeah.
You can talk about the future.
Yeah.
Let's move to that topic. Yes.
Yeah. So I think there's a lot of work to be done, and like Chad just said, I mean, this is peak of the hype cycle. So I think Erica, in your talk, you showed an entire page of serverless projects. Some of them big, some of them very small. How that's going to come about to really have that developer experience of I can compose an entire application, and what are those next steps to make that easy for the developer?
So
go rounds.
I think we're moving down. We've got about a minute. We're moving down. So what does the future look like? There's a lot of opinions about this. We have a pretty strong opinion that the future is moving into creating an entire programming model out of serverless. Like right now you're seeing obviously the early use cases around triggers and event-based programming and change object storage and trigger a function or launch a server, put a message in a message queue, event a function that updates some analytics system or something like that. And that's great. I think those are early use cases. They're getting massive adoption or more adoption now. But I think what people are waiting for is more of a programming model in order to build larger, more complex applications and orchestrate more functions and to be able to do this in a way where you don't have this spaghetti network of, I think there's a term, well, I forget the term, something about your monolith, your poorly organized monolith is not going to be a well-structured microservice, a bunch of well-structured microservices. I think it's a little paperclip joke. But that's even worse when it comes to functions because now we have a proliferation of thousands of them. So one thing that we're working on is a system called FNflow. And FNflow is a way to programmatically build more sort of higher level complex workflows and orchestrations using your native language. So we announced Java at Java 1. We've got a Go experimental library. We've got a Python library. And it's a way to use the primitives of the actual language itself and extend on those. For example, in Java, it's completable future API. But to be able to build more complex workflows and have those farm out to hundreds, if not thousands of functions in the background. But the developer doesn't even have to think about how to handle those, and it's all nicely native packaged up. So we believe that the future is sort of moving towards making it easier to consume for developers, pre-built code, lots of services now that offer pre-built code to pull those in and integrate those into your application without writing any code at all, low code. So I'll end there.
Erica, Alex, you want to talk about the future?
Yeah, it's interesting that you talk about this FNflow because, I mean, that's what IOPipe started as. We initially launched with something that was just like that. We allowed us to kind of build a flow-based programming, and it would automatically scale out things and then run anywhere on any of the phases. And nobody wanted it, at least not then, right? We were a little early. People were still trying to figure out what is serverless, and we're like, look at all these things you can do with serverless, and here's a product, and the users weren't there yet. So I do think that is probably part of the vision of a future of serverless, as well as this ultimate portability of applications. If we can tightly define what serverless is, where it's just a JavaScript function or it's just a jar file, then I think that sounds a lot to me like a unikernel, right? If if 5 lines of code is your application, isn't that a unikernel?
I see Amir smiling here
right?
at the first row.
And then, if you want to make that portable, you can combine it with your Node.js, of course, and you can combine it with your Linux kernel, and you can combine it with your x86 processor, and you can run the whole thing on FPGA, right? And, eventually, these abstractions are going to go further in that direction, eventually, right? And then, of course, observability. So you actually know what's happening with your application as you run it. So you know what functions you're running, where they're running. Because there's a lot of sprawl, right? You think you have a lot of sprawl with Docker containers, right? Imagine when you replace every function in your in a single microservice with a series of functions that you have to then individually manage, right? So we've gone from microservices to nanoservices, and your sprawl problem becomes much, much worse. So we definitely need better tools to manage that problem, and we're going to be seeing a lot of development in that in the next year or two.
Talking about the future, we've just run over, but if you can just bear with me one moment, I just want to say a final word. I really mean this. The future is now, And if you want to be involved in this, this is the time. So this is the point at which Docker CLI may integrate with FAS solutions. This is a time where you may actually be able to get your project, open tracing, Zipkin, whatever it is, integrated into one of these big projects and see that become successful. So we need your help, all of these projects. If you're interested, please get in touch with us. I think you know how to find us, and we really appreciate that and want you to be part of the journey.
Thank you very much to this excellent panel discussion. Now we have a few minutes time for any questions. Please, if you have questions, step forward to the mics over there or raise your hand so I can come to you with the mic.
Hi, hello. Yeah, I just have a comment. I'm really into serverless. I've been working with it for some hobby projects that I'm hoping will be professional projects at some time. But my comment about the future is that right now I think the whole universe around serverless kind of needs to evolve, because right now it's just not upload a function and then it works. You know, I'm working on Lambda, and I have to configure, you know, IMIs and VPCs, and I have to define secrets, and I have to define API gateway triggers and all these things in a mirage of Amazon specific YAML files, you know, in order to just simply get a build flow going, right? And that's and I really love it. It's not that I don't like it, but it took me like 3 or 4 days just to get the basics in, right? So I mean, do you agree that we sort of need the better tooling around this whole serverless endeavor before we can really get it to the masses?
Let me just say a word, and I'll give it over to Erica. So, look, try OpenFAS. You have it running on your laptop in 60 seconds. You can read the CLI guide, and you'll finish it before you finish your coffee. And believe me, don't take my word for it. Let's literally go out there and see what people are saying. It's too complicated on Lambda, but I do appreciate it has its use cases, and it's really well done. But if you need the things that Lambda doesn't give you and you're finding pain points, look at the other projects.
And I just want to answer that. So, you know, so there are tools. There's Apex framework. There's a serverless framework. I think the serverless framework in particular is really compelling because it provides an abstraction and simplification around those primitives. So you don't. I mean, sometimes yes, you do have to go, into specifics, of like AIM profiles and things like that. But it will automatically create those things for you by default, and then you have the power to override them if you want to. And then it supports OpenWhisk. It probably will if it doesn't already support FN. It supports OpenFAS. It's pluggable, so it provides that abstraction for you and simplifies that process. And it's nice because right now it's bridging a lot of the compatibility and portability issues that we might otherwise be experiencing.
Try OpenFAS. I totally agree with you. We're in Gen 1 of this stuff. Remember, I mean, Lambda, I think, I can't say this with authority, but I've heard that it's a service that they threw at the wall, which they do with a lot of services, to see if people would like it. And it's kind of exploded in usage. And so it's a Gen 1. I think you're starting to see lots of Gen 2, lots of Gen 3 services come out that make this a lot easier for developers. And I think all of us up here are thinking about that every single day, about the developer experience. And again, we don't want to take thinking about infrastructure to thinking about configuration files. Like, we haven't gone anywhere. So I think we have to take another step.
Okay, we have a question over there.
I think
yes. What if you have to consume a database? And if you calling these functions as a service thousands of times, this database is going to crash, or it takes a long time or too long time to get the connection. Then it's not. I would like to see this serverless in few 10 milliseconds, but I see some issues there.
So actually, I have an answer for that. The serverless architecture with fast database access, it already exists since the 90s. It's called PL SQL, and it runs in Oracle. I think you have the equivalent in most databases. I don't know. Do you guys have a serious answer to that?
So I guess I had some issues hearing the question, but I'm going to go with what I heard. So, the services, at least like on Lambda, and I know OpenFaaS, for instance, has mode 1 and mode 2 containers, right? So if you do like a mode 2 container, or if you run on Lambda, you have a process that is long living. So you can make a connection to something like a database once. That connection is persistent across invocations. So you don't have those connection penalties necessarily, depending on how you write your function. So you can write your function so it connects every time you evoke it. You probably shouldn't do that. You should probably connect to your database once and maintain a pull, just like you probably always have done. It's just that you will make more maybe connections than you used to, because those processes are recycled at least on Lambda, the process recycled every 4.5 minutes to every 4 hours. So just be aware of that, but you can at least within whatever time window that is before your process is garbage collected, you can maintain those connections. And then you use tools, you use your logging tools, you use things like IO Pipe, or you use CloudWatch, or you use whatever it is that you're using for monitoring to know if you're having problems, and then you fix them.
Yeah, I think that also speaks to there's confusion and people don't know how to start building applications with serverless and with functions. Because we've got all these old problems that we had with our monolith that we took along to our microservice. Because microservices just really do fewer things, but they're still kind of like monoliths. Functions are really designed to do one thing really well, and to be stateless, input, output. And maybe the answer is one that we don't like, and maybe your function shouldn't be doing that. Maybe that should be a microservice that your function can then be smaller, and it can make use of that. And I don't think that functions were ever designed to remove the microservice or the Docker, the monolith. If anything, I think when you see a lot of competition and a lot of competing ideas, it brings everyone else up. And I'm hoping to see frameworks like Express.js, Flask, etc., up their game to try and be on the level, because really serverless is about delivering the developer experience, right? How fast can you iterate? How fast can you get the code out? How easy can you make it? And I think that's what we need to think is an ecosystem. It's one tool. If everything looks like a hammer, like a nail, you're going to hit it with a hammer, right? Everything is not a nail.
Max, you had a question.
Yeah. So I took some time looking at serverless, and if you know me, I'm generally a positive person. But I'll do my best imitation of Yoda and say that serverless, dog, the future is. And the reason I say this is, I'll give you a specific example. So a colleague of mine, Nima, we built a serverless spec, so essentially a set of tests, and then we ran them across all of these, except for FAS. I don't think because at the time, I don't think it was ready. Anyways, we could try it after. So anyhow, here's the reason I say that the future is dark, is when we ran some of the tests, literally all of them failed compared to running the same things on a stand-up application on, say, Cloud Foundry. Compare, right? So then you say, well, specifics. So one example is that you run with a memory-intensive application. Well, on Lambda, it works pretty well, but on Azure or some other like Google functions, it fails, or vice versa. And of course, on OpenWhisk, same things. You run things like, for instance, the multiple requests. So then you expect the serverless platform to kind of spin up things very quickly. Well, then you see a very slow ramp up. Or best one, you run something that actually goes and waits and then does an operation later. On Lambda, it times out. You literally can't use it. Now, that was at the time, okay? Things might have changed. But literally, basically, when it comes from portability, impossible, unless you have one function. When you come from performance, it's going to be very hard to kind of beat, like, setting up something. When you run on cost, it wasn't very clear that, with the cost of like, say, Docker engines or paths going down, that would be better. So for me, it's interesting, but I don't see the future. Maybe I'm wrong, though. So
I just wanted to say that I think that's a great point. And that's sort of entering the trough of disillusionment. But I certainly think that all of those problems are solvable. And I could probably, you may have used iron functions if this was previous to 2 weeks ago. And I think I remember the report, and I think we sort of had a pretty basic response was like, do this, do this, do this, do this, and it fixes 90% of those problems or 80% of those problems. But it is all about education, all about making it easier to consume, all about documentation to be able to solve some of those problems. And I think we're getting there. And as Alex said earlier, it's about hearing feedback from the community and about evolving as open source projects and about getting better and better. And then we'll get there, including the big vendors as well. I mean, they're listening, they're getting better, they're involving more CPUs and higher memory and bigger timeouts and all sorts of things. But again, to Alex's point, the hammer hits the nail. If you want a long-running process, function might not be the right thing to execute that on. So it's architecture, it's best practice, but it's also evolving all these projects together. So I was hoping for some real hard challenges. Oh, those are really pretty easy to solve. So we can follow up on that one.
Yeah. So yeah, well, one thing that was mentioned at Serverless Conf, which I really liked, was make sure it's not a nail first, right? Like, no, it's not. It's not always a nail. Make sure it's not a nail, right? Like, do see if you can do it with serverless first. Serverless is relatively new, right? Lambda is relatively new. It's maturing. It's a couple of years old now. A lot of the other services are much less mature. Google Cloud Functions and Azure Functions, OpenWhisk, right? They're all relatively newer than Amazon. And even Amazon, right, is still doing a lot of these really basic things like longer timeouts. The performance of a Lambda CPU-wise, or especially disk I/O-wise, is not necessarily fantastic. Disk I/O is pretty slow, actually, in my opinion. And it's just maybe, something to be aware of. And also, as much as, like, I'm a big proponent of, like, these are events, you should process them quickly. Sometimes it matters more about the scale. So, like, I have an application that has Kinesis readers. If let's say I have 10 shards on Kinesis, that means I can have 10 concurrent readers. Well, according to how many events are actually processing, it depends on how many concurrent Lambdas are actually running. So what happens is I'm getting an economy of scale, and auto-scaling that happens per request, not per 5 minutes, not per 10 minutes, not per hour, right? My auto-scaling happens at a per request, right? And that matters to me more than the fact that my requests might take, like the individual events might be taking 20% longer or something, because it's more about the fact that I have auto-scaling at a far more granular level, right? It's at the order of milliseconds rather than hours, which is what it would be if I were consuming Kinesis with an EC2 cluster.
Okay, I think we have
Are we done?
over time. Thank you once again to this fantastic panel of experts. Please give them another hand.
So thank you all for coming. One last thing I wanted to add is if you're interested in the serverless topic, tomorrow at the Mobi Summit, we'll have a Birds of Feather session about that with many of these panelists in the afternoon, tomorrow afternoon at the Mobi Summit. Thanks.
Thank you all for being here and have a wonderful trip home. Thank you for joining DockerCon. Goodbye. Good night.